Okay, so this is the new version 8.5 of the Tycho software, and what I'd like to do is demonstrate the new overlay options as well as the new AAVSO format export. So I've loaded up a few images here into the image manager, and I'm going to go ahead and view these images. And what I'd first like to show is the overlay options that have been introduced. So the solar vector, this is a vector that shows the trace of the sun. So here we have a comet, for example, and the idea here is to validate that the tail of this comet has the similar vector as the solar vector. So in other words, sun position would originate from here and then produce this tail on the comet. So 101 degrees, and you can see the arrow pointing in this direction. So it matches up, and if we wanted to do a transform, it will follow that behavior. So I've done a rotation where north points up in the image, and you can see that the arrow still points in the direction of the tail of the comet. Now, the other thing I'd like to point out is the ability to overlay object information onto the image manager, or rather the image viewer. So load known objects, this is a feature that's been around for some time now in Tycho, and it's quite nice. It will compute the precise position of the objects in the field of view. And so what we can go ahead and do here, I've just turned off the rotation for this example, is this comet, there are several features of it, if you will. So we want the main feature, the nucleus, if you will. So I'm going to go ahead and toggle these off and then concern only with the nucleus of it. And also, if I want to, so you can see the animation. I've kind of done this before, so you can see how it computes the path of the comet. But really what we want to do is go ahead and apply object information. And so when I click this, essentially all I've done is I right-clicked on the object and I choose Apply Object Information. And this is going to present those attributes of the object as an overlay in the image viewer. So elongation angle, phase angle, the Earth distance, sun distance, phase angle, bisector information, speed, position angle, and so forth. And if you want to, you can go to Settings, Overlay, and adjust which pieces of information you want to have displayed. So you might have speed PA displayed elsewhere, so it might be redundant, so you can toggle that off. Or distance, if you don't care about that, you can toggle that information. And also there is a way to manually, you can type in an object number and name, and then search for it here. So if I have Comet C219Y4 and do a search on that, it will bring up these results. And so I could choose it this way, click OK, and that would return the same results here. So it's both ways work just fine. If you are already working with the known object module, then this is a nice shortcut to apply object information this way. And we could do this one more for another object over here, 2004. This is a very faint object here, 2004 R109. So its computed magnitude is said to be 24.6. That's because it's a 4 AU out, so it's going to be very faint. But nevertheless, if we wanted to, we could apply that object information. So this updates correspondingly with the Earth distance and sun distance are now associated with that object. So it's one way to overlay additional information if you want to show that in a capture. So again, these settings here can be adjusted. If you do not want to have the solar vector, you can uncheck this box or correspondingly, if you do not see it when you first try out this version of Tycho, keep in mind that it is an option here that you can simply check. So the solar vector, check it, and then it's going to display here. So that's a nice feature to have. It's, again, just another option. So if you don't want any of that information, then you uncheck all of those boxes and then go from there. And as I mentioned, there is also, in this version, additional support for the AAVSO format. So I've loaded up a field that has a few variable stars in it. And what I'd like to go ahead and do here is just show one example of that. So we can go to photometry, load variable stars if we wanted to, and this would load up the known variable stars in this field. So when I do that, it's going to go out to a Vizier server, which you can select from this list if you want to. And from that server, it's going to retrieve the variable star index. So it basically requests all of the variable stars that would be within this field of view. And if you're wondering why does it look like this nice blue background false color, again, that's another feature, false color. You can turn that on, turn it off. That's just however you wish to present the information. So these are the variable stars, the green boxes here. And what you can do, you could either double click on one if you are in close enough proximity to it. So when you double click on it, it will select the appropriate variable star on this list, or the corresponding one. So if I go to this one, for example, I can zoom in, double click on it, and this is what is selected. So this is designation HAT P6, and it has a min-max magnitude between 10.54 and 10.55. So it's amplitude is 0.01, 0.011, and period in days is 3.853. So it gives you all that information for a given variable star. If you want to, you can also right-click, View Star Info, and this pops up another dialog box here. It will show you not only the variable star information, which is shown here, but also the catalog information. So if you have the Atlas 2 catalog information loaded up on this field, then you will have these different magnitudes available, BVRI and Sloan magnitudes, and it can compute B minus V and then show you the color temperature of that star versus the sun and so forth. So it's just another nice feature to have. So basically you can go through this list, you can click on different variable stars and it will highlight them in the image viewer as well. So if we wanted to, I know that Galvar1 is a variable star in this field. So here it is, Galvar1. And I've kind of done this example before, so I'm just going to show how to generate the photometry on this variable star and then how to export that in the AAVSO format. So what we want to do is generate a photometry set, and to do that we create two markers, marker 1, marker 2, and then basically that's simply saying that the object is stationary. So normally with Tycho it's typically going to do photometry of a moving object. That's how it was originally built, but you can do that of a stationary object just as well. So we create two markers, both of them at the same position. So that's all I've done here. And then we generate a photometry set from those two markers. So I click this button here, menu item, and you can see we're generating photometry information. And what I can do at this point now, I have my measurements. There are 128 measurements. Each of them correspond to a given image in the image manager. So now if you're wondering why does the view here look different, that's because these images have not been normalized. The background of each image is not normalized. So if I want to, I can turn on the automatic background level, and that will generate a consistent background level in memory. So in other words, at runtime. So normally if you are working with the synthetic tracker, then that's part of a calibration step where you actually normalize the images and it creates new image files that have that consistent background level. But with photometry, then typically you won't do that. Instead, you'll just preserve the signal as is, and whenever you generate photometry measurements, that's as working off the original signal. But that's kind of a tangent. So here we have the measurements, and what we want to do is go ahead and create the light curve. So I can plot all sets. There's only one here, and you can start to see this variable star pattern here. Now, again, I've only loaded up 128 images here. The original data set had 512 images, but this should be ideally still sufficient. Now, if we wanted to, we could also clean up some data points, but let's just go ahead and compute or do a find period. So from 0.5 to 12 hours, and this says 1.03 hours is what it came back with. Now again, I'm not going into all the details on how to do variable star measurements at this point. In fact, this one, it actually used a V filter, so you might want to have your star catalog. You might, in this case, want to use the V potentially in that respect, but it has also been suggested that Sloan R with Atlas is ideal. So that's for another topic, but for now I'm just demonstrating how to basically generate photometry series, and then once you have generated those measurements, then how do you export that? Because that's the new feature in version 8.5. So you go to the photometry sets and File, and you simply say Export AAVSO. So you can choose that option, and then you would specify your observatory code, star identifier. So this would be GalVar1, for example, whatever chart you're using. So if you have a known designated chart identifier, you can put that. Otherwise, you can put, in this case, Atlas RefCat2 or similar. So just something to designate the chart in question. And if you wish to include the error mass of each entry, then it has to know the latitude, longitude, and the coordinates of the star in question to compute the error mass. So it will populate these fields by default. You can double check to make sure that they are correct, but it only requires this info if you want to include error mass information. So you can click OK, and then give it a file name. So I click 1.txt. And what it has done there is it went ahead and saved it. Now if you want to view it, you could either open up Explore, or very easily enough, just right click, choose Edit, and then you can see the output results. So we have essentially the name of the star, the Julian date, and then the magnitude at that point in time, magnitude error, and so forth. So this is the basic extended AAVSO format, and then that should work and be compliant with the AAVSO format. So that is a new feature, and I'm certainly open to hear any feedback on that. Another nice feature that has been added to version 8.5 is the ability to click on different data points in the light curve, and it will then show the corresponding measurement entry in the list here. So if you might see potentially an outlier or one that deviates from the computed curve, then you can determine where it is as a data point here in the measurement window. And it will also show that in the image viewer as well. So again, different data points can be selected like this. You can select several data points, but it will still only show the first one that matches in that list. So looking at this one, this is here it is in the image viewer. And we can also take a look at the object profile. So this is another new feature here. Object profile itself is not new, but the ability to choose the half Gaussian profile. So that gives you a bit more real estate to work with. So you see only the one half of it, and then a more extended set of data, an extended tail, if you will, of the Gaussian. So here you can see with this line here, this is the sky annulus. So here you have the target, the dead zone, and then the sky. So the sky background is computed from dead zone to the sky annulus. So this is the range here. If you're not sure, you can always go to photometry, modify aperture settings, and essentially this is where you can see the radius. If I adjust it, then it should update the green line here. It will move that out. And then if I adjust the dead zone, then you will see that result there as well. So I simply use the defaults here, which typically work quite well. So 4 pixels radius, 2 pixels of dead zone, 9 pixels for the sky annulus. So again, if I zoom in and show that, this is what we have here. So we have, again, a nice tight profile on the object, some dead zone, and then finally the sky annulus. Now, there is, you might think, some interference from this one, but it's not a problem for the sky background because it will remove those outliers from the sample. But in any case, is this an outlier? Is this a data point that we would want to remove? That's not questionable, but if you wanted to remove it, it's obviously very simple to do so. You can click delete, and then you could recompute the period from that. So the period list, now we have, it's a similar result, still 1.03. Anyway, that's about it for these new features. There are several more. If I look at the changelog, here we have a timeout to abort processing for the tracker. So you can go to settings on the tracker and specify a timeout. So if you're doing synthetic tracking, that's a feature there. And again, export AAVSO format, I've covered that. Load and display known variables in the field. Again, that's what we're doing. Load variable stars, that's the new option here. And essentially, again, solar vector, I showed that, and the elongation phase angles, that's nice to have. So other features of interest would be, so pre-processing, debayering is improved, so that is its own function here. And so that's nice to have. And then finally we have some other nice to have functions that improve the overall performance of the software. So that is about it for this video. So thank you for watching, and see you next time.